In this video, we are going to learn the general form of separable differential equation and non-separable differential equation. Non-separable. For example, the differential equation dy dx equal to xy is separable differential equation where we can group x with dx and 1 over y with dy. We can group the y terms with dy, x term with dx, and then we can integrate it. It's a separable differential equation. One more example, dy dx minus xy equals to x, also a separable differential equation where we can add both sides with xy so that we have x plus xy. To take note here, we have common terms xx, therefore we can factorize it. Then after that, we can group one y terms into left hand side and then x term on the right hand side. These are some examples of separable differential equation, but not all the differential equations are like this. For example, dy dx minus xy equals to 1 is non-separable differential equation because we don't have common factors here. This is a number, this is x. You cannot factorize out. Let us try. Even though you add both sides with xy, we still cannot separate the x and y. One more example, dy dx minus 1 over x y equals to ex. This is also non-separable differential equation where we cannot factorize out the x at the denominator part and x at the top. Therefore, we cannot separate it like what we did before. So in general, those separable differential equation can be written as dy dx equals to a function fx times a function fy. For example, the function fx for the first example is x. The function fy for the first example is y. For the second example, function fx is x. Function fy is 1 plus y. This is general form of the separable differential equation. For non-separable differential equation, it can be written as dy dx. dy dx plus py equals to q, where p is a function or a constant, is a function or is a constant, and qx is also a function or a constant. For example, dy dx minus xy, the negative x is px, and the constant 1 is qx, is 1. For the second example, the negative 1 over x is px, and then the qx for this case is an exponent x.